everyone. In this video, we are going to go over the answer key for problem set 12. Problem set 12 covers our very last chapter of content in this course, which deals with the idea of correlation and regression. As a brief reminder, this idea covers associations, which is where we deal with two or more interval ratio level variables, and we're bringing it back to our very first idea from Unit 1, the idea of the relationship between independent or X variables and dependent or Y variables. And so with those things in mind, let's start off with question number 1. A criminologist finds that the number of prior arrests, or X, and the likelihood of being denied bail, Y, in St. Charles County have a correlation coefficient of R equals 0.65. And we have a couple bullet points below this, so let's start off with the first one here. Given the above scenario, interpret the strength and direction of this correlation. And so as we mentioned in this week's lecture video, our correlation comes from our Pearson's R score right here. And if you recall, Pearson's R is measured in a range from -1 to +1, where our center score is 0, where there's actually no correlation at all. And so if I were to interpret the strength and direction of this correlation, the first thing that I always like to take a look at is the direction, because it's pretty quick and easy for me to figure that out. All I have to do is look at the sign of the number of R itself. Am I seeing a positive number or a negative number? And when I see R equals positive 0.65, I know that I am dealing with a positive association. So I can check that off here. And then in terms of actually describing the strength of this overall correlation, I would say that this is a pretty moderate correlation overall. If we were to think of this in terms of the range and you were to plot this out on the scale from 0 to +1, we're definitely over the halfway point, right? We're above 0.5, but we're not quite all the way to 1 or that perfect relationship. Again, we're never going to see that in real life in the social sciences. In general, we kind of use 0.7 as that cutoff mark in our heads to say it's a really strong relationship. And so in this case, anything below that 0.7, I'm going to put in that moderate category. And so if we were to use this and interpret this within the context of our scenario here, we could say our correlation coefficient of 0.65 indicates a moderate positive association between prior arrests and likelihood of being denied bail. So, as the number of prior arrests increases, the likelihood of being denied bail tends to increase. And this would make sense in actuality, right? Because if a judge was trying to assess flight risk, if you had been arrested prior times as well, that might be something that they take into consideration when they are determining whether or not to have bail be an option at the time of pretrial. And so let's move on to bullet point number 2. Calculate R squared and interpret your results within the context of the problem to receive full credit. Okay, starting off with R squared. All that we have to do here is take our R value that was already given to us in question number 1 and square it. So that's just multiplying it by itself. So you should get a value of 0.4225. Or if you were to convert that into a percentage, we know we can just multiply that quickly by 100 to get 42.45%. And once we determine this, we know that R squared is describing to us the variation of one variable in relation to the next. And so the key here, and what a lot of people tended to miss in this case, was interpreting these results within the context of the problem. And this is really our key here, because if you stopped at this point, you probably got partial credit because you're still answering part of the problem here. But this is really the key information that we want to report here. And so what does this actually mean for us? 42.45% of the variation of those who are denied bail is explained by the number of the individual's prior arrests. And so that's what the R squared value allows us to actually show here. And so it's explaining variation. That is our key word when it comes to R squared. So if you are ever asked to interpret R squared moving forward, please make sure that this word is included in your interpretation. That is the key word I will be looking for for moving forward because that's what you're essentially describing there. Bullet point 3. Interpret what R-square value means in terms of the variation in the likelihood of being denied bail as explained by the number of prior arrests. In other words, explain what the R-squared value means in the context of the problem. And so here what I was really looking for was more of a conceptual explanation of what R-squared actually is independent of your calculation up here. So it was more about the idea of really getting at the heart of what this concept of variation was. And so here, R-square refers to the percentage of variation that has been observed in regard to bail denial and is explained by the number of prior arrests the individual has received. So it's really just describing those two variables in relationship to one another and which one is describing the variation in the next. And so a lot of folks actually included this explanation down here. But again, what I was looking for was more of that conceptual. Again, I left in text feedback a lot of the times for the difference between these two. I'll try and make it a little bit clearer moving forward. But again, if you see and interpret your results within the context of the problem listed here, please make sure to do that as well and not just leave this blank. This is always going to be an important step here. And this was more of that conceptual question, really just getting into what the R-squared value means in terms of the variation conceptually in and of itself. Our last bullet point here for question number 1 is, does the correlation value of R equals 0.65 suggest that prior arrests cause bail denial? Explain why or why not. And so, if you recall back from our lecture video this week, one of the biggest takeaways I wanted you to have from this entire class, and I even stopped the video and had us take a breather there, was the idea that correlation does not equal causation, right? This is a huge idea within statistics that I see get conflated all of the time. And so even though we are describing correlations, relationships, and associations here, we cannot say that prior arrests are causing bail denial in this case, right? We can just say that they're correlated, it has something to do with it, there's a relationship happening here, but it's not actually causing this to occur. There is not a causal relationship here. We know this for a couple of reasons. One, because it's not a perfect -1 or +1 relationship in terms of our R square or our R value here for Pearson's R at the beginning. Again, when it comes to our social science world, I can't think of a single example where you would ever see that in reality. And so, again, don't ever expect that to pop up. We're never going to have a causal explanation within our social world. And again, just by nature, correlation does not equal causation, again, in our social world. Sometimes within the natural sciences, you will see causal effects. But again, for our social sciences, that is not going to be the case. And so what this means is that we're doing a pretty good job overall of explaining some of the association and variability here, but there are some remaining unobserved factors that we aren't accounting for that could also explain some of the reasons that judges may be denying bail as well. And so keep this in mind. Overall, the biggest takeaway from this problem was this statement here, that correlation does not equal causation. So keep that one in mind for the rest of your life. Big takeaway there. Question number 2. Researchers studying police patrol hours X and reported burglaries Y in a St. Louis neighborhood find that the correlation coefficient between the two variables is R equals -0.7. Similar structure to what we saw with question number 1, but this time we only have 3 bullet points. So let's take a look at bullet point number 1. Given the above scenario, interpret the strength and direction of this correlation. So first thing I always like to do again is take a look at the direction of the correlation. Here I see that we have a negative sign, so I know that I have a negative relationship this time rather than a positive one. And this time I see that the strength has actually increased relative to what I saw before. And so even though we technically got more negative, we're actually inching closer to a -1, which in that case is a good thing if we're trying to strengthen that relationship, right? So in this case, I would actually classify this as a correlation coefficient of -0.7 indicates a strong negative relationship between patrol hours and number of reported burglaries. Because again, it doesn't matter necessarily that this is more negative in that case. As long as we're moving further away from that midpoint of 0, which is where the no correlation is occurring, that's where our strength increases. The closer you get to an R equals of 0, that's where the correlation actually decreases. So the closer your R value gets to either +1 or -1, the closer you're going to get to that perfect relationship. And the closer your R value gets to 0, whether that's positive or negative, the less correlated your two variables are going to be. So keep that in mind. Alrighty, second bullet point here, calculate R squared and interpret your results within the context of the problem. Same idea as question number 1. R squared, keep in mind that when you square a negative variable, it does turn out positive. So we end up with 0.49 or positive 0.49 or 49%. So if we were to interpret this within the context of the problem, we could say that 49% of the variation in reported burglaries is explained by differences in police patrol hours. Okay? And lastly here, interpret what the R-square value means in terms of the variation in burglaries as explained by patrol hours. In other words, explain what the R-square value means in the context of this problem. So again, more conceptually based here about the relationship between the two variables of X and Y in relationship to one another. R squared refers to the percentage of variation observed in reported burglaries that can be explained by the increase in police patrol hours. Again, same idea. If we were to add this idea of the fourth bullet point here, correlation does not equal causation. Didn't really feel the need to reiterate that this time around, but just keep that in mind. Again, in our social world, that would apply in the same way here for question number 2. And lastly, with question number 3, here's where we're actually moving into applying our regression equation in and of itself. And I've provided that to you here. So let's take a look at question number 3 together. A study examines the relationship between the number of meetings an individual has with their probation officer per month, X, and the number of technical violations they have per month, Y. Following a year of data collection, researchers determined the following regression equation. So we have violations equals 3.5 minus 0.25, and then in parentheses, we see probation meetings. So keep in mind that the base formula for a regression equation in this case would be y equals, and then we have our y-intercept here minus our slope times our independent variable or x here. So I filled this in just with the context of the problem here for us to visualize it a little bit easier. I think that'll help us plug it in here below. And so our bullet point here for our first one is asking us to interpret the y-intercept in the context of the problem. So the first thing we need to do is actually identify what that y-intercept is. So if it's helpful for you again to chart that out, what I can do here is say again, our 3.5 is our y-intercept here. So 3.5 equals our y-intercept, and our slope equals -2.5. And so that's our overall regression equation here. So the y-intercept is 3.5. What does this actually mean, though, in terms of the regression equation and then within the context of our problem? So the y-intercept, if you think about it in a chart format, is the point in which our linear line is going to cross our y-axis. And because of that, that's where we're going to reach our 0 point. So the y-intercept in and of itself is a value of 3.5. But what does this actually mean for our problem? This value represents the number of technical violations an individual is predicted to have if they do not attend any meetings. So again, 0, because that's where we're crossing that point on our y-intercept, with their parole officer in a month. In other words, an individual in this study is expected to have 3.5 technical violations in a month if they do not attend any meetings with their probation officer. And so that's what they would be predicted to have if they did not participate in any meetings at all, right? And then we are supposing with this treatment, essentially, of actually attending these probation meetings, that the number of violations should decrease with every probation meeting that they actually attend. So that's where this slope comes in below. So let's interpret our slope within the context of the problem. Our slope is a value of negative 0.25. So this value represents the number of technical violations predicted to decrease with each additional probation meeting per month an individual has with their probation officer. In other words, for every probation meeting an individual attends, the number of technical violations they are expected to have decreases by 0.25. So, overall, with these two first bullet points, keep in mind a couple of things. Our regression equation here is a predictive model. So that doesn't mean that for sure someone that was in this study that attended 2 probation meetings is automatically going to have 3 violations, right? Our key word here in both of these is a predicted value. And this is based off of the study amount and data that we had already collected. So if you were to say this definitively, that based on this data, someone that attended 2 meetings is going to have 3 violations, that is incorrect, right? This is the predicted value. So keep that in mind as you are interpreting these values moving forward. This is a predicted value. Secondly, the slope here is negative. So I can say decrease here by a value of 0.25 without saying decreases by negative 0.25, because I'm inferring here by saying the decrease value here and not needing to repeat myself doubly here. So keep that in mind when I interpret that. I'm saving myself a little bit of time here by implying that as well. Let's go over our final 2 bullet points here. This is where we're actually using our regression equation to plug in our information to actually predict what individuals would have in terms of technical violations if they were to attend a certain amount of probation meetings in a given month. So let's start off with bullet point number 3. Use the regression equation above to predict, again, we see that key word here, the number of technical violations for someone who had 2 probation meetings in a month. You must show your work and interpret your results within the context of the problem to receive full credit. So all you really have to do here is take this existing regression equation, which was given to you at the top of the problem. Honestly, you can just copy and paste it right down here, which is what I did, and plug in the number 2 to your x, which is your independent variable of probation meetings. Once you do that, you can take 0.25, which is our slope, and multiply that by 2 to get a value of 0.5. So here's the next step once you do that here. And if you do 3.5, which is our initial y-intercept, subtract that by 0.5, you'll get a final value of 3. Next step here is to interpret that within the context of the problem. And so an individual who attends 2 probation meetings in a month is predicted to have 3 technical violations per month. So again, keyword here is predicted. Again, it would not be appropriate to say an individual who attends 2 probation meetings in a month is going to have 3 technical violations per month or had 3 technical violations per month. Because again, this is a predictive equation. It's not a certainty. So very similarly here with our final bullet point, we are just using a different amount of probation meetings here in our predictive model. Use the regression equation above to predict the number of technical violations for someone who had 6 probation meetings in a month. Show your work and interpret your results within the context of the problem to receive full credit. Here, again, we have 6 probation meetings, so I'm just going to plug in a value of 6 for my independent variable here. If I multiply 0.25 for my slope by 6, I get a value of 1.5. But again, since my slope is negative, we are going to retain our subtraction symbol here. So I get 3.5 minus 1.5 to get a value of 2. In the context of this example, we would interpret this as an individual who attends 6 probation meetings in a month is predicted to have 2 technical violations per month. And so what the idea of this overall problem is really getting at is the more supervision or the more contact an individual is having with their probation officer, hopefully the more they are, keeping attuned with their scheduling and keeping on track after they have been released from the criminal legal system. And hopefully they're keeping a little bit more on track the more that they are keeping in contact with their probation officer. So the more contact that they're having, hopefully the more they are keeping on track relative to those who are only checking in, a couple of times a month. So that's information that, folks in probation and parole could use to see what the ideal number of probation meetings a month is overall. And so with that being said, if you had any difficulty with these respective problems, please let me know. Again, as I mentioned at the beginning of this video, this is our very last chapter of content. And so if you're having any difficulty with it, please let me know before your final quiz. And best of luck with both this final quiz and the rest of your finals. And I wish you the best of luck with all of your studies moving forward as well.